So much of math comes down to just solving an equation. So we might have an equation that looks like this: x plus 4 equals 11. And to solve an equation means find out what the value of that variable is. So this variable x is some unknown number. If we add 4 to it, we get 11. We can do this one in our heads, right? Something plus 4 is 11. That something must be 7. Voila! Just like that. With math and algebra, however, we want to be able to show the proper steps mathematically here to prove that x does in fact equal 7. So what we will do in this situation, we will look just at the left side of the equation for a moment. The left side of the equation has our x plus 4, and we will now consider, how do I get x by itself? If I'm adding 4 to x, what would get rid of adding 4? Subtracting 4. The inverse operation of adding 4 is subtracting 4, and that is what I will show right here, minus 4. That's the inverse operation. Now on this side of the equation, I have x plus 4 minus 4, and that will leave me with x. On the other side of the equation, interestingly, if I subtract 4 on the left side, I must do that on the other side of the equation as well. This is the subtraction property of equality. Properties of equality tell us that whatever we do to one side of the equation, we must do that to the other side in order to maintain equality. So in this case, if I subtract 4 from both sides of the equation, on the left side I'm left with x, and on the right side I'm left with 7. That looks pretty good. The next step is to check the solution to be sure it's accurate. Checking the solution means we rewrite the original equation and we plug in the variable with its value. X plus 4 equals 11. I'm claiming that x equals 7. That means I replace x with 7, and I now have the equation 7 plus 4 equals 11. Looks pretty good so far. Then we evaluate 7 plus 4, just looking at that side of the equation. 7 plus 4 is 11. On the other side of the equation, I still have 11. 11 does, in fact, equal 11. That means this equation checks out. There's another way to write this work, and you may see this sometimes, particularly in some textbooks. We will start with the same equation, x plus 4 equals 11, and we are still doing this subtracting 4 on both sides of the equation. Sometimes, however, it's easier to see it and visualize it if we put it in the same line as the equation. That means I rewrite the equation as x plus 4, leave a little bit of a space, and put equals 11. Now, to show minus 4 on both sides, I put it on the same line here. Minus 4. Minus 4. So I have x plus 4 minus 4. Well, if I start with a value, add 4, and then subtract 4, I'm going to be right back with that value. On the right side of the equation, I have 11 minus 4. This will give us the same result. On the left side, I have x. On the right side, I have 7. Same solution, and then I go through the checking process, the same as I did with the first example. Solving an equation that has subtraction in it is very similar to solving an equation that has addition in it. This equation, x minus 2 equals 3, is presenting us with a situation where some number is lessened by 2 and results in the number 3. We can think about that mentally. Yeah, if it's 5, that will work. Wonderful. Showing the work, that's the goal. Understanding how to show work with single-step equations helps us build to be able to show work with more complex equations down the road. If I have a number and I subtract 2, and I want to undo this operation of subtraction, the inverse of subtraction is addition. That means I will add 2 to the left side of the equation. Let's make that a little clearer. I will add 2 to the left side of the equation. If I add 2 to the left side of the equation, I must add 2 to the right side of the equation. X minus 2 plus 2, brings us right back to x, and we have isolated the variable. On the right side of the equation, 3 plus 2 is 5. The key here is showing what is happening to both sides of the equation. Whatever I do over here on the left, I must do the same thing on the right side. That maintains equality for this equation. Checking the solution, very similar. X minus 2 equals 3. I replace the variable with its claimed value. We claim that it's 5, and now we will prove that it is in fact 5. 5 minus 2. Don't be so concerned with what's on this side of the equation. Just think about the left side. We do each side separately, independently, and then compare the results. On the left side, 5 minus 2 is 3. On the right side, well, there's not a whole bunch to do over there. I just bring down the 3. And that works. 3 does equal 3. This shows that with the equation x minus 2 equals 3, if I add 2 to both sides and I get x equals 5, I can check that solution and prove that it does in fact work for this equation.